Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone is doing all right up there. I'm not sure how I'm going to title this. I'll title it how I title it when I title it. But what I am sure of are 3 goals for today. 3, not 4, 3. Our first goal is to show that there's another way to construct congruent triangles, and it's the SSS method. Side, side, side. Copy the 3 side links. Our second goal is going to see how ASA, or angle side angle, leads to another triangle congruence pattern. Our third goal is going to be why the angle side side, or the ASS pattern, does not create congruent triangles. No giggling. Alright, our first goal, show that there's another way to construct congruent triangles, the side 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 method. In the previous lesson, we saw that we can construct congruent triangles by copying an angle, a side, and an angle, resulting in the following congruence pattern. This is the angle side angle triangle congruence criteria. We have this pattern, we have congruent triangles. Okay, very important that we recognize that pattern. The second pattern we learned about was the side angle side, resulting in the following congruence pattern. I copy a side, I copy an angle, I copy a side, and this is the side angle side congruence criteria. So if I have this pattern for congruence, or this pattern of congruence, I have 2 congruent triangles, which means that I can go a step further and list their corresponding congruent parts. But we'll get into that a little bit later on how to use congruent triangles. Right now we're just recognizing them. Okay, so today's lesson we learn of a third pattern that allows us to construct congruent triangles. This is the side, side, side congruence pattern. So I'd like to show you that I can copy this triangle ABC onto line L, which I will label L, that I didn't do it previously. We're going to copy triangle ABC onto line L at point P. I'm just going to copy the 3 links. Copy the 3 links. Okay, here we go. Where's my compass machine? Ah, there you are. Okay, so I'll copy the length AC first. So I'm going to put a needle on one vertex and a pen on the other. Make a little mark to indicate that I copied length. Bring that down here. And I have copied the same length. These I know are the same length by construction. I built them that way. The next length I'm going to copy is length AB. I'm going to copy length AB. Let's see here. Needle on this side, pen on that side. Okay. Now, I don't know exactly where it's going to intersect, so I'll just make a longer arc, okay? And that way that I'll be guaranteed that my third side length that I copy will show me where that intersects. Because I don't know where this point is yet, okay? Because I haven't copied my third side. So let me copy my third side here. Okay, now what I'm going to do is I'm going to connect the dots, and I should have 2 identical triangles. Now, where did I hide my ruler? There you are. Okay, so I know from this point to this point is the same length as this point to that point from A to B. These are congruent, okay? And if I connect these guys, Bird's got a lot to talk about today. I probably can't believe how many people are on campus. Alright, hopefully you can see that. But I've also copied this guy, and hopefully you can see that these 2 triangles appear to be identical, same size, same shape. And again, I can copy triangles by copying one side length, or actually copying all 3 side lengths to another location. So I'm going to go ahead and review all of this and state an example of each so you can have it all in one place in your notes. So let me clean all this up and I'll be back. I'm back. So let's go ahead and continue with our first goal, which was to show there's another way to construct congruent triangles, which was side, side, side. Now we have 3 congruent patterns to look for to determine if triangles are congruent. Our first is angle side angle, or ASA congruent triangle criteria. Now I'm moving around the congruent marks to reinforce to you guys that They don't have to be in one place, but as long as I have an angle, a side, and an angle where the side's included, I have the angle, side, angle congruence criteria. The second congruence pattern that we got by construction that we built is the side angle side, or the SAS congruent triangle criteria. So if I have a side, the included angle, and the included side congruent, I can say that I have congruent triangles. And our third construction that led us to get congruent triangles is the side, 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 or the SSS congruent triangle criteria, where if I have 3 pairs of congruent sides on 2 triangles, I have congruent triangles. Alright, so we need to recognize these patterns, and sometimes we have to find the hidden congruences to determine if we have these patterns. Remember, there was 5 hidden congruences that I talked about. There was vertical angles. What was the other one? Vertical angles. There was, let's see here. Vertical angles, there were alternate interior angles of parallel sides. There was reflexive, there was bisecting, and there was midpoint. So sometimes these congruences are hidden by one of those methods, and we need to recognize when we do have them. And it's always good to mark your congruences on your triangle so you see these a little bit more clearly. So why recognizing congruent triangles is important? Okay, this is actually a bigger picture idea. We are working towards another proof style. Our first was a transitive argument, right? 2 things are equal to the same thing. Those 2 things are equal. We're able to bring them together. Well, our second uses congruent triangles. Once we argue the triangles are congruent and write a congruent statement, we next list the congruent corresponding parts, which will allow us to reach a conclusion about a certain situation. So what comes to mind right now is if a point is on a perpendicular bisector of a segment, then that point is equal distance from the endpoint. So when I looked at that section the first time, I'm like, oh, okay, I'm going to use a congruent triangle argument style, but I couldn't because I haven't taught you about the side angle side congruent triangle criteria. Because if a point is on a perpendicular bisector, we have a reflexive side, we have 2 right angles which are congruent, and we have the bisected segment, so I get the other pair of congruent sides on that congruent triangle criteria, which means that the diagonal sides must be congruent because those are corresponding parts of congruent triangles, and so since those are the same length, the point on the perpendicular bisector must be the same distance from the endpoint. So we could have actually argued that using this style, but we actually argued it using the Pythagorean theorem. So let me go ahead and check off our first goal. And we're going to now move into our second goal, and that's to see how angle side angle leads to another triangle congruence pattern, all right? So let me clean all this up, and I'll be back. I'm back. So let's go ahead and wrap up the second goal, and that's to see how angle side angle leads to another triangle congruence pattern. Keep going back and forth. All right, second goal continued. The angle side, or AAS congruent triangle criteria. Here's an example. I have 2 pairs of congruent angles, and I have a side that's not included. It's not between the 2 congruent angles, so it's a little bit different. But please notice that the congruent sides are next to the same pair of congruent angles. They're both next to the angle of one congruent arc. This must happen to have angle side congruent triangle criteria. We know the third angles in both triangles must be congruent because of the 3 angles of a triangle adding to 180 degrees. This leads us to angle side angle. If we don't have them next to the same congruent angles, we don't get angle side angle. So here we have our 2 original congruent angles. We know the third must be the same. So if I erase the second pair of congruent angle marks, which is what we started with, we see that this is angle side angle. If the congruent sides were not in corresponding positions, meaning they're not in the same positions, we would not be able to create angle side angle congruent triangle criteria like we did above. Okay, so right here is an example of a situation that's not angle side. look, this congruent side is next to the angle with one arc. This congruent side is next to the angle with two congruent arcs. Because when we add our third, not our three pair, our third pair of congruent angles, we do not get the angle side angle congruent triangle criteria. So again, if I erase my second pair of congruent angles, or my two congruent arcs, notice I have my side that's between the congruent angles. I need this for angle side angle. I don't have that. So if the congruent sides are not next to the same angles, it's not angle side angle. Very important that we recognize that. All right, so I'm going to check off our second goal. I have one more goal to talk about. Let me clean this up, and I will be back. I'm back for the last time, I promise. So let's go ahead and get into our third goal. That's going to be to investigate why the angle side-side pattern does not create congruent triangles. Before we get into this, I'd like to tell you a little story about Mr. McAvoy. When Mr. McAvoy was in his geometry class and I was learning about the angle side angle triangle criteria, congruent triangle criteria, the side angle side congruent triangle criteria, the side congruent triangle criteria, and the angle side congruent triangle criteria, I thought I'd be funny and I'd ask my teacher, hey mister, what about the angle side congruent triangle criteria? My teacher, without skipping a beat, looked at me and said, Chris, the only angle side in this class is you. Touche, touche. Well played, mister. Well played. All right, so back to this. So I want to convince you that if I copy an angle, a side, and a side, I can make completely different triangles. So we cannot guarantee that triangles with the angle side congruent pattern generates congruent triangles. I would like to construct two distinctly different triangles with the angle side congruent pattern. And by the way, the book calls it side angle. It's not side angle. Just like the planet that people call Uranus, it's not called Uranus. It's Uranus. Say it right. It's Uranus and it's angle side. I'm so sick of how goofy people get about things that make you giggle. Go ahead and giggle. Okay, giggle. Get it out. I'm done. All right. So I'm going to copy an angle, a side, and that should be good enough for me to show you that I have two distinctly different triangles. So let me start off by copying this angle into two locations. I'm going to go purple. I like purple today. I'm feeling a little purple. All right. All right, so remember I mark how far out I'm going to measure my angle for how much it opens. So I'll do that twice. Okay. And then I measure how much my angle opens at that length. Okay, it's a little, I remember to mark a little bit below that, but it's okay. Okay. And let me connect these, and I've copied the angle. Copy the angle. Okay, I've copied the angle. Those angles are the same. They should be the same. All right, so I copied the angle. Now I'm going to copy this side length onto this. Where's my compass machine? There you are. So let me copy the side length onto this. So I need to measure needle on one end, pencil on the other. Needle on one end, pencil on the other. Needle on one end, pencil on the other. You know, and as I look at this, I think I'm going to make this one go a little bit longer here. And you'll see why in a second. Okay. Okie dokie. So I have one more side that I need to copy. Now, when I copy this side length, I'm going to make more of an arc. Okay? And you'll see why. I'm going to make more of an arc. Let me copy this little guy. So notice, and this is why this doesn't work. Notice this arc crosses twice. Because in one instance, remember, circles show equal distance, right? So in one instance, I can connect like this. And in the other instance, I can connect like this. And if I erase all the marks that I made for the construction, let me use an eraser because I don't want my hands to be any dirtier than they need to be. If I erase all the marks that I used to make this, you can see that I do in fact have two distinctly different triangles, even though the triangle has an angle that's congruent, an adjacent side that's congruent, and the second consecutive side that's congruent. So the angle side does not guarantee that we're going to get congruent triangles, with the exception of one case, and that's the next lesson. All right. So I'm going to go ahead and end it here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.